I'm Martin Ewart. I'm the CEO of Earthwave. We create a number of products and services, all based around satellite data. We work a lot with the European Space Agency. And today I'm going to talk about, in particular, multi-sensor data discovery. I'll talk a bit about marketplaces, but really my focus is going to be on the path from data and bringing those multiple different data sets together from different sensors through to visuals in order to give intelligence or earth science to actually give findings of on the Earth's surface. I'll be in that spirit. I will be talking about two of our particular initiatives. One is Earth Hub, and one is SFC Labs. I'll probably spend a bit more time talking about Earth Hub, which is our main initiative at the moment. But then I will lead on to SFC Labs, which has some pretty nice visualizations to show towards the end of the presentation. So I guess just to reiterate what I was saying there, I'll talk about how we start with data discovery, and visualization is a part of data discovery. Before you then move on to more advanced visualizations with the data, and then that's where you get the findings, the earth science, you understand the change. So I'll start with Earth Hub, as I mentioned. So Earth Hub is our SaaS satellite and sensor data discovery platform. Now, before I go into exactly what Earth Hub is, I will just take it back to basics. And so let's talk about the basic aims of a satellite data provider. Now, this will seem fairly obvious, but it's always good to kind of frame the conversation. So they want to demonstrate the benefits of their data, clearly. And they want to find more use cases of data. And the reason for that is if you can demonstrate the benefits and find the use cases, then you're going to open up more sales and commercial opportunities. And that's what it's all about. You have many companies launching constellations, satellites, and it's all about trying to have as many use cases as possible and really engage with as many different downstream clients as you possibly can to try and give high quality solutions to them. So how do you go about doing that? Well, I guess probably the main way is direct consultancy. There's a lot of that. Satellite data providers often consult directly with clients to understand their requirements and create bespoke solutions that can, be of a range of different levels of how advanced they are. Then you kind of get almost the other side, which is the marketplaces. The marketplaces will be more generic, generally showing something about data sets, but it may be harder for companies to advertise the merits of their data and how they can be used in advanced ways. And so often companies are part of initiatives to, they'll often be working with governmental organizations. A lot of the satellite data providers will work with the likes of the European Space Agency and NASA in collaboration with scientists and various other consortia to show the benefits of their science and their data and validate it and really help show how it can be used. And then, of course, there's direct marketing to show the benefits. So what are the kind of common needs that all four of those items have? Well, really, the common needs are that you need to make data discovery easy. You have to be able to show where the data is in space and time. You need it to be easy for people to use. You need it to be easy for, if you've got a sales team, to be engaging with potential clients. There's one thing showing really detailed visuals about the data, and it might be some, really high resolution, hyperspectral data or something. But actually, before you get into that conversation, showing context around where the data is, where it is on the Earth, what the coverage is, how often it repeats. These are core requirements about working with the users to give visual context and actually understand the different combinations and use cases that you have. Now that's quite challenging, and there are a number of challenges that come into play here. For a start, not all data is equal, and nor should it be. As we, as many people will be aware, you've got spatial resolution. High spatial resolution is going to give accurate representation of an instance in time. This is great if you want to know a particular situation at a point in time. But then you've got temporal resolution, and this might not be as detailed information, but it might repeat more often and allow you to show detailed change. It's often quite rare to get very high spatial resolution and high temporal resolution. Normally there is a trade-off here. And indeed, actually, if you're looking at change on the Earth's surface, you may not even need that accurate instance in time, but you need accurate change. So for example, if you're looking at the change of a mass balance of a glacier, you don't necessarily need to know the exact mass of the glacier, but what you do need to know is that the change you are recording is accurate, because that is what is interesting. That is what drives if you want to know the change in the mass balance of a glacier, that is what's ultimately feeding down and driving sea level rise. It's all about the change. Then what if it's cloudy? Well, you could have really high optical data, but you need SAR information if it's cloudy, of course. So that's different. It might not be as high resolution, but at least it can see through the clouds, and there's a lot more findings you can get there. Then there's hyperspectral data, which is different again. And there are many non-image data types. So you've got altimetry, weather, ground sensors. The list could go on. And you've got all these different requirements. And this feeds into often many users, many customers, they need to combine data from multiple sources. It's often not used in isolation. So a very common behavior pattern is that people will work with freely available data from the likes of the European Space Agency and NASA, maybe the Sentinel data or the Landsat data, and then they complement it with targeted data sets. And the applications here are endless. I put some examples here, but I could have made a list that is hundreds of lines long. If you're looking at shipping routes, you might look at sea ice location combined with weather, with buoy information, with AIS data for the ships. You might want to look at the difference between radar and LiDAR elevations to understand the attributions of a surface. Maybe that is over snow or over trees. It really depends. You'll mix the data with airborne surveys and various imagery. Of course, I've already mentioned optical and SAR combinations to handle different weather conditions. But the point I'm getting at here is that visual context is what drives the data discovery. All of these different sets of data, users need to know where it is spatially and temporally, the details about it and the benefits of it, and which data is coincident with it. And that is what will differentiate the sales process. If you can show that and advertise the merits and show the combinations, it can very much drive the initial sales conversations, allow users to start understanding the potential of the data before you get into the more advanced use cases. So this brings us to EarthHub, and I will start by showing something that we've built for the European Space Agency using our EarthHub platform. Now this is a video, it's an ESA video, and it's CS2EO. You can explore and combine ESA and NASA altimetry data. Now, it allows you to intersect the different data sets, and you can explore the combinations interactively and then download them easily. It's very simple and easy to use. It's a key part of this is the simplicity. And there's 3 services that we actually built around this. And I'll talk through those 3 now. So as you may be aware, a few years ago, ESA aligned Cryosat-2 with ISAT-2 so that they follow the same trajectory every 31 hours. And we now allow you to explore those combinations. So these are all intersecting data sets over sea ice. Now we're showing it over land ice. And it's all example driven. So people can click these different examples we've seen on the left-hand side and explore them. We have airborne data in here as well. So you'll see here, these are airborne data sets. And again, there's many different sensors in here. And crucially, the usefulness is to combine these with satellite data, and these are combined sets of data. We also have another product that shows change in elevations, and we make this at Earthwave, but it's also available in the platform. And it allows you to show the change in the elevation on the Earth's surface. And a gridded product is created off the back of that. But again, you want to combine these to get different findings, and the results of which we're showing on here on the video. And this is a time series of change, but I'll go into that a little bit more later. I'll also just talk about some other uses on the platform. There's new features that have been added recently. This video here is showing Sentinel data intersecting with altimetry data. And you can actually get both Sentinel-1 and Sentinel-2 and allow to explore the different combinations, again, to get a feel for what's happening there. A key part of the platform, that video was relatively fast, but it is really simple to use. It's example driven. You can start by selecting an example, which will have certain date ranges and times populated for you, and selected the parameters for combinations. And then you can just modify it easily yourself for your needs. And we're a great believer that I think a lot of people, they like to work from examples. It's very rare you start and just build from the ground up. You like to start from somewhere. And feeding into that is this repeatability argument. So any query we run, for example, we give a URL that people can share, and it will run exactly the same query. So you can save it, save it in your notes and use it next time, modify it slightly. So it gives people a base to work from. This URL on the left, it's not the prettiest, but it's a bit like on Google Maps. If you want to share a location, you get a URL for that location. It will show you where it is. So it's very easy to share. There are other challenges as well that satellite companies will find. Building an easy to use aesthetic data access UI is actually quite expensive and time consuming. You need to support integration with a lot of different APIs, and satellite companies clearly want to keep control of their data. And one thing I didn't mention there is we index spatially and temporally where data is in the EarthHub platform, but we don't host it. We can host it, but there's no need to. We index where it is. People can query, find the metadata, understand the benefits of the data, but then when they go to actually access these data sets, it goes back to the data providers. And so this is what EarthHub is. It's a SaaS satellite and sensor data discovery platform. It's for satellite data providers. It lets more people discover the data and find use cases, finding those combinations that I've mentioned. Just imagine if you've got access to millions of ground data points and you can show those combinations with your satellite data. And you can advertise the benefits of the data, gives a fast and effective cost-effective route to market, and hopefully convert the visits to sales. This is also not a marketplace. It's more of it is a SaaS product where it's either gray or white labeled, where a satellite company can quickly get that data access platform that they can use and then advertise the merits of their data. And maybe they choose to allow combinations with, say, freely available data sets like ESA and NASA data, but they don't have to. They could choose to allow combinations with other commercial companies if they've got partnerships, but again, they don't have to. So it's all about allowing the satellite data companies to use this to, for the merits of their data, while keeping control of the data. And at risk of repeating myself, enable combinations of data, satellite, ground data, flight campaigns, etc. So really, again, to show the benefits. So for EarthHub, we have a number of partners already that we're working with. We're building out to show the different benefits of their different data sets. And if you're interested in working with us and partnering with us, we're very much looking to extend those partnerships at the moment. So please do contact me. My email address is there, but it will also be repeated later at the end of the presentation. Moving on, but in a similar spirit, I'm going to talk now about SFC Labs, which is a new initiative that we've spun out from Earthwave, which is all about combining multiple sensor data sets again, but in a much more advanced visual way. So this is now building on, if you've got an initial platform where you can find different combinations of data, how do you then start creating advanced visualizations of those data? So what we've created is a 4D interactive visualization platform. And it was actually built as part of the European Space Agency's Digital Twin Antarctic initiative. We brought together many sets of data, and it allows to demonstrate the benefits and enhance understandings of the work being done. It's particularly targeted at being able to go to decision makers as well as the general public and expert users, to tell them, to show the merits of the data and increase understanding. And we built this actually using the Unity gaming engine, and it supports VR, so virtual reality, really to help give context around these data sets. And I'll now just show a story. So this will go relatively fast, but this is a story of a region of Antarctica. Now this won't quite do it justice. If you've got VR, it's much more immersive, and that's great. You can look up and down and around, or a big screen again, you can explore it. You can freeform explore this. This is just a YouTube video. But this is showing the Amundsen Sea sector in Antarctica. And in particular, we're looking at the Thwaites Glacier, and it's Thwaites is thinning. Now you would expect thinning down near the ocean, but they found from satellite measurements that it's also got localized rapid changes. And these are drainage and filling events thousands of kilometers, not thousands, many kilometers below the Earth's surface. And these are subglacial lakes. And they have a drainage network. And we can see this when we peel back the layer. And all this water is flowing down to the ocean. And this is fresh water. So this is mixing with the salt water. And obviously that is going to have an impact on the ocean. And what we see here is, as the video rotates over, I will just pause it for a second. Oops, we can see the YouTube at the bottom, but never mind that. This red area here is actually melting under the ice shelf. It's melting faster as a result of these drainage events. And so you can really help contextualize the understanding of these scientific data sets and what is actually happening. Because if the ice shelf melts faster, it will ultimately break away quicker, become an iceberg, and then more ice will flow down from the surface. And just to finish off this video, we'll have a little roller coaster ride under an ice shelf, which just appreciates the fact that this is truly immersive and you can explore, peel back layers, do whatever you want if you're a user. Also, I'll just show this video. Now, this is something that ESA created using this experience. You can see the VR in action here. The big screen there is the full Antarctica experience. And this is a bunch of scientists, PhD students and postdocs using it to actually understand the impacts and understand all the different data sets. I think you can see me in the video. I was kind of sat there in amazement as they're actually discussing the interactively what was going on there. And it was really informative to see how they could use that and the benefits. And so that leads me on to the benefits of such a tool. Well, it enables demonstration and promotion of innovations. We're now extending this tool that was focused on Antarctica, but we're extending this to all types of surface around the globe. And this can be working with all different types of companies, from energy companies. You can show energy networks, offshore wind turbines, how the energy networks flow back to back to land. You can look at coastal flooding and erosion, deforestation, land management. It allows you to contextualize change in a very advanced way. And underpinning this is the same advanced spatial temporal combinations of data sets that underpins the Earth Hub platform, except it's doing this in this more immersive, it is serving up these tiles of this more of the actual data itself to allow these immersive structures. And it, as I've mentioned already, it's there to engage with stakeholders. We found that this has gone on a lot of senior decision makers' heads of the VR to tell them the stories of what has happened, help them understand the science. We've even had it on some ministers of parliament, so some MPs' heads, various other senior leaders in the community to, again, help understand the science, understand the work that's being done. The other interesting thing, this picture on the right is actually a demonstration at a museum. There was lots of, there were about 15, 16-year-old school children there at a particular day at the museum. And we demonstrated the platform. You can actually see the VR again in action. There's also this big screen over here. And it really helps educate the children about these processes, the uses of satellite data, understanding change that's happening. And we actually took it to another level. As I mentioned, we built this in the Unity gaming platform. Well, we thought, well, why not just make a quick game on all these Antarctic data sets? And this was very little work. We just overlaid a glider flying through some rings. And as it flew through the rings, it told a story of the changes on the surface. It was really engaging. And museums are very interested in having now unstaffed stalls here that will allow the promotion of, again, these different stories, allow innovations to be shown with this content that's refreshing. And the other thing is it enables collaboration. If you've got lots of scientists putting their data into a platform, lots of innovators, they can actually put them in, and then they can show, again, the combination of the data and actually understand the changes in a more collaborative way. And I think one of the things that this does as well is it does help obtain funding for programs, because it really puts that context around the data. So again, we're looking for partners. Contact us if interested. If you've got interesting stories, data you'd like to add, we're really keen on building this out. This is the generic email, info@sfclabs.com, but you can also contact me directly on my email address as well, which you'll see on the last slide if you wish. But yeah, we're definitely looking to partner with people and create these interesting stories here. I'm just getting towards the end now. Sure. This is the team in action, and they're a great team. We've got a great diverse bunch. We're presenting here. We're presenting interactive visuals. We've got we're hosting a seminar and a discussion session. And it's been a great team and a great journey and building out these different tools. Just quickly, here are some of the other services that Earthwave run. Again, all built on multi-sensor analysis, bringing together different data sets. Top two are showing time series and change. And in fact, to be honest, the bottom one in the middle is also showing time series and change, just in different ways. And these have all been bringing together these different data sets. And so I'll finish there with a big thank you there's my email address. If you want to talk to us about anything that Earthwave do, in particular the Earth Hub initiative, which we're really pushing in a big way at the moment, and SFC Labs and the work we're doing there with the visuals, please get in touch, and it'd be great to speak to you. And yeah, any questions? Thank you very much.
Perfect, wonderful. So thank you again, Martin, for the presentation. And again, as you mentioned, as you sat in the room, you know, in amazement with the postdocs and the PhDs, that's how we were feeling when we were watching again what you were presenting. As it's very advanced and again very interactive, and you know, provides really a great insight into really understanding all these processes that are happening. So I do believe it's very important, again, the work that is being done. So we really feel, you know, we support that fully, and you know, our congratulations to you on the amazing job and the works that's happening. So perfect. Regarding obviously the contacting you, so they have the opportunity to send you again an email as you just displayed it, but also they can find you on the speaker list where there's a contact info attached that they can request a private one-on-one networking session, and I encourage them to do so, either if it's to individuals that watching this live right now, or if you're watching a recording. Make sure to reach out to Martin, and you can collaborate on the earth science and the, you know, the other amazing projects that Martin is working on. So regarding the questions, so I will give you one question from my side, as we still have time for that. So looking into the future, let's talk about that, Martin. What are some of the key trends and developments that you see shaping the earth science industry? And how is Earthwave positioned to respond to these trends and continue to innovate in this field?
So I think the key trends that we are seeing is, it's a topic I touched on a lot there, really, is the fact that users want multiple sources of data. It's just rare that people will just use a single satellite data set. You just take any form of artificial intelligence or machine learning problem. You generally want some form of ground truth data, ground data, ground sensor data, maybe soil moisture content or whatever, to combine and then to compare that with the satellite data sets. You need that to validate data. You need it to train models in machine learning context. You need it in so many different applications. And finding those combinations is really where we see the industry going, opening up the knowledge of what is available. There are so many different satellites and constellations being launched, and it is a changing where suddenly analysts within companies or scientists within academia, you name it, they need to know what is available to help them. If you work in an insurance company, what can I find that will help me understand flood levels and the trends and the changes and things like this? It's becoming increasingly important to help and educate all people about what is available, what is possible, and like I say, these different combinations and how you can combine data and use them. And that's very much where we see it going. And we believe we're positioned quite well here, particularly with the initiative around the Earth Hub initiative, as well as the advanced visualizations which are built on top of that. Because if you can get this rich combinations of data that you can be indexed and people can use, then that will really be a big enabler for the industry to actually understand what is possible and really enable them to do advanced analysis.